Hi all, I'm Puneet. My project was on SOLR, which is a purchase search platform based off of Lucene. The aim of the project is to demonstrate that SOLR can be combined with Mahout to add semantics to search results. So the basic flow would be to first generate term vectors from SOLR and then run Mahout on those term vectors to generate Mahout vectors. And once we have Mahout vectors, we can do a lot of stuff. We can run various machine learning algorithms on top of Mahout vectors. And then once we get the additional information like what clusters the documents naturally group into or what classes do they fall into, we can join them with the SOLR search IDs, SOLR document IDs, and attach them back to the search results, thereby making search semantically richer. Also, once we have these insights, what we can do is we can pass it to something totally different, like a visualization engine, and see a pictorial representation of Mahout output. So, Solar comes up with some example documents. So, that's what I have used for this project. So, the first step is to index those documents to generate the term vectors. So in Solar configuration files, we can mention which term in that document will contribute to the term vectors. And once we have the term vectors, we can run Mahout to get Mahout vectors. And then later we can run various machine learning algorithms. I have chosen Mahout clustering as a proof of concept. And then we can get the Mahout cluster dump on which we can do a variety of stuff. One of them can be to extract the cluster labels, join it with Lucene document IDs, and then feed it back to Solr to get the cluster information displayed in the search results. Or we could also transform this output using various Linux commands of awk, sed, and grep to generate a temporary output which can then be used by other downstream processes like, say, for example, visualization. So in my project, I have used D3 bubble chart as the downstream process to represent Mahout clusters. So the first step is to set up Solr. For Solr, the Java version needed is 1.7 to run Solr, and to build it, we need Ant version 1.8. To compile in the Solr directory or example directory is fairly simple. So let us first enable generation of term vectors in schema.xml. So Solr has many configuration files in conf folder. Schema.xml describes the schema of the documents. What are the fields in that document? And solrconfig.xml describes the various components used in Solr and how you want to enable or disable those components. So Solr has a plugin architecture. So technically you can just replace any one component by an external component and it just works. So in my setup, I have chosen the term name as the basis of generating term vectors. So term vector, as we all know, is just a vector representation of document where in this case, the terms would be coming from the field name of every document. I chose name because it's there in every document, so we'll have less sparse vectors. And in solrconfig.xml, I have enabled clustering by default. So as I was saying that Solr has a plugin based architecture. So an ideal approach probably would have been to just replace the clustering component by Mahout clustering engine. But I took a different route in which I overrode the Solr code where it was creating its own clusters to actually call a shell script which runs Mahout commands. This approach gave me a lot of flexibility that I could change the commands and the output locations on the fly without having to recompile Java. And I could use the powerful command line arguments, command line tools to basically post process the data. So my Java code in Solr was merely a driver for Mahout shell script and later a parser for parsing the results generated by Mahout. So for Mahout clustering, yeah, the version is important. I learned it the hard way that not every Mahout version works with any Solr version. Mahout zero point 0.7, which at least I used in my assignments, works with 3.6.1 Solr. However, I guess in zero point 0.9 they have made it compatible with 4.6. But there's an easier approach to just check out Mahout code and see the POM file. There we'll know what Lucene version it's compatible with. So now in the next few slides, I'll just go command by command uh, of the shell script that is run from within Solr, which basically runs Mahout commands. The first one is to convert Lucene vectors into Mahout vectors. So the command used is, so Mahout has this Lucene.vector argument, which knows how to read uh, Lucene vectors, term vectors, and the output is familiar. We get Mahout vectors where uh, for every document we have a vector describing the document, and where the index in each of these is basically the index of the word in the dictionary. Next, once we have these vectors, we can run a clustering algorithm. I've chosen k-means on top of Mahout vectors. Now, this command has some interesting command line arguments. The -cl basically tells Mahout that it's free to use random seeds as the cluster centroids. So to begin with, uh, there are no clusters, so Mahout can use random seeds, and from there on, it will keep on improving upon uh, its cluster definitions. -k is basically the mm, number of clusters we want, and dm is basically the distance measure. Uh, it's the it's through the distance measure is that Mahout figures out how close two vectors are to be identified as belonging to the same cluster. Once we run this command, the output is in a binary format. So we run another command on top of that to basically get the output in text format. That is the cluster dump command. Now, once we have this command, this is a big step forward because we have converted Lucene Solr term vectors into readable cluster information generated by Mahout. So to describe the sample output, the n here is the size of the cluster, n equals 3. So this cluster has 3 documents, and BL-18 is the cluster ID generated by Mahout, and these are GB18 is basically the document ID. So next is this is the main command actually, which now transforms this cluster dump output of Mahout into something quite readable and directly usable. So it transforms it into a JSON which is stored in flare.json file. Now this JSON is directly usable in a D3 bubble chart visualization. So there is a root node in this JSON, and it has bunch of children. Each child represents one cluster. The name of the cluster is derived from the two most prominent terms in that cluster. So if you see here, there are top terms listed. So the way I chose cluster name was I picked first two terms as the cluster name. So 1 and euro is the cluster name of the cluster, which is of size 16 and henceforth. So once we have this output, we can generate a visualization, and also the Java code uses this output and parses it to get the cluster names. So we have the cluster names. Next we need is what all documents belong to a particular cluster. For that, I run another command which outputs a multi-line file where each line represents Solr document ID and an empty line represents a cluster boundary. So parsing that file is pretty simple. We keep on reading line by line. The moment we see a empty line, that's where the cluster ends and another begins. So now we have all information that we wanted to add to Solr index. So for the visualization part, once the shell script has post-processed everything, it copies the data, that is flair.json, and all the required HTML and JavaScript into the Solr's web root. So how does it all integrate? In the Java code of Solr, I basically see if flair.json exists. If it doesn't, that means Mahout has not been run yet. So I run Mahout, and once I have the results from Mahout, I basically parse it using Google's JSON library to get the cluster names, and I parse cluster docs, which is the second file where one line is the Solr document ID and an empty line is cluster boundary, and get the list of documents belonging to each cluster. So I'll quickly show how it all ties together. So the first thing we do is clean up the any of the past Mahout results, then run the Solr server. It stops and starts listening to incoming HTTP connections at 8983. Next is the uh, Solr web portal. Here if you see, there are no cluster informations yet. That is because if you go to the console, it clearly states that it couldn't find index, so it's starting Mahout. The reason it didn't find index was we cleared it. Now it's running Mahout, and once it is done running Mahout, we'll be able to see the clusters here. Now this is a important addition to Solr, because this time these cluster information is not generated by Solr but Mahout, but it's integrated in Solr as if it was natively generated by Solr. And in the end, we can also see a link for visualization. And once we click that link, we see the visual representation of the cluster generated by Mahout. So I'll quickly show the demo. Here I have a Solr instance where there is no change. So I'll just run the instance. So I have a server already running, so I'll quickly kill it and try starting this guy again. So this guy is now listening. If we go back to the portal, we'll be able to see what Solr generates without any modification. So here there is a cluster list, but these clusters are generated by Solr's default cluster algorithm, which is some caret to cluster algorithm. Now I'll do the same thing, but this time the clusters will be generated by Mahout. So this is my cluster. First thing I'll do is I'll clear past results, and then I'll start my server. Next I'll submit all the documents to get indexed, and now we can go back to the portal and refresh this guy. So once we refresh, we'll see that this guy says that there are no clusters. That is because we had cleaned the Mahout results. So now it is running Mahout, and we can go and check what's actually happening. So here, if you see right now, Mahout has just run the uh, it has just converted Lucene vectors into Mahout vectors. Now it has just finished with running k-means clustering algorithm, and then finally it has done the cluster dump, and we have post-processed the cluster dump and generated the flare.json which will be used in visualization, as well as getting the cluster names and cluster docs, which will be used in getting all the documents which are part of that cluster. Now if we see, this information is what Mahout generated for us. So this is uh, a big step forward, because we are showing in SOLR clusters generated by Mahout as if they were natively generated by SOLR server. They get integrated very well and almost identically to how they were being generated, natively in SOLR using the default clustering algorithm, which is the carrot clustering algorithm. Now, if you click on visualization, here we see the uh, visual representation of clusters generated by Mahout. And if we hover over any of the bubble, so bubble size is basically cluster size, and the bubble label is the top two terms used in the cluster. And of course, you can play around with the controls. So the key, key take home points from this experiment is that it is possible to do a round trip from SOLR to Mahout to SOLR, which means we can keep on improving and enriching SOLR search results with Mahout insights. And I have shown through clustering, but you can have any Mahout function run on Mahout vectors like classification. So we can keep on enriching the search results. Also, Mahout is Hadoopable. So if there is more workload, we can push the processing onto a Hadoop cluster and get better response times. And it demonstrates that once we have Mahout output, one thing we can do is enrich the search of SOLR, and also we can post process the Mahout output, maybe even offline, to any downstream data mining process like visualization to have a better view of data. So yeah, that was my project. Thank you so much.